Hello viewers, I'm Kausalya. Today we are going to solve example 2 in chapter 13, surface areas and volumes. So here the problem is the decorative block shown in figure is made of two solids, a cube and a hemisphere. The base of the block is a cube with edge 5 cm and the hemisphere fixed on the top has a diameter of 4.2 cm. So find the total surface area of the block. So here you see, if you are unable to understand the problem, you can read it twice or thrice, right? So here you see what are all the things we have. We have a cube and a hemisphere, right? So the base of the block is a cube. So the base is cube, right? Whose length is 5 centimeter and the hemisphere is fixed on the top of the cube, right? Whose diameter is 4.2 centimeter. We have to find the total surface area. So here, just look at this diagram, right? So what is this? This is a cube, right? And we are having a hemisphere which is fixed on the top of this cube, right? So we have to find the total surface area. And you see the edges of the cube are having 5 centimeters. And this is your hemisphere, and here we are having 4.2 centimeter as diameter. So what is the total surface area, right? So here the key thing to be noted here is, okay, just listen carefully. So how many sides does a cube has? A cube has 6 sides, okay? So even if you have a cube, okay, Rubik cube in your home, you can check it. So totally you see 1, 2, right? 3, 4, and here it is 5 and 6, right? So there are 6 sides of a cube. So what is the total surface area of a cube? What is its formula? Its formula is 6 times of a square. And here the value is given as 5. So just you can substitute it over here. Okay, that's fine. But you see, 5 sides are okay, right? 5 sides of the cube, you can just directly take it. But what about the 6th side? That is the side on the top. So here you see, this is in this side, we are having a hemisphere, right? So we are having a hemisphere, and what to say, this hemisphere covers some area at the bottom, right? So in this case, when you consider this side, you have to be more careful, because you see, so when you consider the total surface area, so here you have to take this area of the hemisphere also. It's fine, right? Because you have to consider. Then, but this hemisphere covers some area of the cube here. Can you notice that? Can you understand? Because you see, this is the top portion of the cube, right? And on this area, I am having a cube. I am placing a cube. So this cube covers some part, okay, some area down here. Can you understand this? So whenever you are calculating the total surface area, right? Or fine, let me show you with this book. Wait. You see, this is the top portion of the cube, right? This is the top side of the cube, and here I am having a hemisphere like this, right? So here we need to find the total surface area. So here we are having a hemispherical area, so you have to include the cross-sectional area of the hemisphere, right? But what does this does? This hemisphere, this covers some part, okay, some portion of the top surface of the cube. Can you guess? Because here I am placing this. So I am including the curved surface area of the hemisphere. But what does this hemisphere covers? This hemisphere occupies this portion of the cube, right? Can you guess? Can you understand? This is the top surface of the cube, and here I am placing a hemisphere. Okay, just assume this as a hemisphere. So this hemisphere, this occupies this some portion on the top surface of the cube. Yes or no? Yes, right. So here what we have to do is, obviously you have to subtract this area from the total surface area of the cube. Right. So our formula goes like this. You see, total surface area of the cube plus this cross-sectional area of the hemisphere, right, minus this hemisphere covers some area at the bottom, as just now I explained. What is the shape of it? It is a circle, right? Wait, let me show you again. So this is the shape of a circle, right? So we are subtracting the base area of hemisphere, which is nothing but a circle, right? So what is the formula? Total surface area of the cube is 6a square, and curved surface area of hemisphere is 2 pi r square minus the base area of hemisphere. This is just nothing but a circle area. So here it is pi r square. So 2 pi r square minus pi r square becomes simply pi r square. So now just substitute the values. So what is A? A is nothing but side of the cube. It is 5 and pi is 22 by 7. And what about the value of r here? You see, the value is given as, that is the diameter is 4.2, right? So what about r? It is 4.2 by 2. So just substitute the values, and when you cancel out the terms, finally here we are ending up with 150 plus 13.86, which is nothing but 163.86 centimeters square, right? So here in this problem, the key thing which you people have to understand is, that is by placing a hemisphere on one side, okay, on one side of a cube, right? This hemisphere occupies some area on the top portion on this side of the cube. Okay, that is a key thing to be kept in mind, because here we are in this chapter, we will be going to discuss about lot of different kinds of shapes coupled together. Okay, just in the previous things what we have studied, if it is a square, it will be a square, it will be a rectangle, or simply it may be a cone. But here we are combining the shapes, right? So whenever the shapes are combined, the key thing you have to keep in mind here is, because in the previous case, you see, the cone and the hemisphere is surmounted on the cone, right? That is what we saw in example 1. There is a cone, right, and there is a hemisphere which is surmounted over it. There is no, what to say, one doesn't affect the other. Okay, one area doesn't affect the other area. They both have the common, this diameter as a common thing, not any other thing, right? But what is here? Here we are placing a hemisphere directly on the top of a cube. So whenever a hemisphere is placed on the top of the cube, what it does, it automatically covers some area on the top surface of the cube, and that too, that area is just like a area of a circle, right? So always do keep in mind that base area of the hemisphere, this is nothing but area of the circle, right? So whenever you look from the top, that is the top view will be like that. So this is your hemisphere and this is your side of the cube, right? So that's the reason here why we are subtracting that base area of the hemisphere. So finally, we are ending up with the answer as 163.86 centimeters square. Again, always keep in mind, you should always mention the units then and there, right? So that's all. If you have any doubt, let me know in the comment section. Thank you.